Good morning to all. So we are going to discuss the topic modulation in principle of electronics and communication. It is very important topic. So when we know the concept of the modulation, then we are able to understand about the amplitude modulation, phase modulation, frequency modulation, even in digital communication, digital modulation like ASK, FSK and PSK. So it is the very important concept, modulation. So let's start. So what is the learning outcome from this session? The learning outcome from this session, after completing this session, we can explain the modulation and its needs in practical communication system, analyze analog modulated and demodulated signal, because when we deal with the modulation we extend the topic to analog modulation. So these are the contents. First of all, with the definition, then the modulation index. We know about the modulation index. What is the modulation index? Then we have to know about the baseband signal and bandpass signal. Upon this modulation index and the definition of the baseband and bandpass signal, there is some exercise. Then we go further for the need of modulation, and in the last, the summary of that topic, that is in covering the mind map. So modulation index. What is modulation index? As you can see, the modulation index is the simple ratio of master signal amplitude and carrier signal amplitude. So you can read it here. In modulation index, the modulation index describes the ratio of the amplitude of the modulating signal to the amplitude of the carrier signal, as you can see, where M is the modulation index, AM is the peak amplitude of the modulating signal, and AC is the peak amplitude of the carrier signal. There is another extent of the modulation index definition, that is the maximum and the minimum of carrier amplitude or master signal amplitude. So you can see that here is another definition of the modulation index, that is in the form of the maximum and the minimum amplitude. So A max minus A mean, it is the ratio of A max plus A mean. So this is the basic and simple definition. So we can further to the next slide. Depending upon these modulation index, the modulation index has three conditions. The first one is the over modulation, and second one is the under modulation, and last one is the exact modulation. It is depend upon the value of M, as you can see in the slide. When M is greater than 1, then this is the case of the over modulation, and when M is less than 1, then this is the case of under modulation, and when M is equal to 1, this is the case of exact modulation. So there is a detail over modulation, and these are the sum point. I can read it for you. Then when the over modulation M is greater than 1, that means amplitude of the message signal is greater than the amplitude of the carrier signal. The carrier cutoffs and the reverse phase, which separately distort the audio signal. This distortion creates extra sideband which can interfere with the adjacent ratio channel. This is highly undesirable. That means we don't want this case. And the under modulation, as you discussed and we see, M is less than 1, and this is the desirable cases and it is the favorable cases. These are the sum point. The carrier amplitude never drops to 0. This is the standard desired state, as I discussed, for AM broadcasting. The audio is reproduced clearly, but power isn't used in the efficiently as it could be. Exact modulation. This is the ideal case, and as you can see, when M is equal to 1, that depends AM is equal to AC, because when m is equal to 1, from the formula we get the maximum, massive signal amplitude is equal to the carrier signal amplitude. So you can see in this picture, when we see this picture, this is the simple definition of the modulation index, that the massive signal is superimposed in the carrier signal and it is transmitted to the destination. With this simple example, with this simple images, I am trying to clear the concept of the modulation, where someone is the message and the vehicle like bicycle, car or airplane is supposed to as a carrier, and the destination is just like a playground, Ujjain or somewhere to China. So depending upon the message signal and depending upon our need of the communication, we use the carrier as bicycle, car and the plane. Okay, so this is the simple and the image concept for the modulation. So modulation, there is another definition, that the modulation is the simple conversion of baseband signal into the bandpass signal. So first of all, we have to know about the baseband signal and the bandpass signal. As you all know, the baseband signal is the low frequency signals and bandpass signal is the high frequency signal. And this baseband signal and bandpass signal can be characterized with the help of its bandwidth. Okay, for the baseband signal, the bandwidth is comparable with the modulating frequency. The example is audio signals and voice signal. As you can see in this diagram, here in this diagram, the lower cutoff frequency is 0. It is denoted with FL, and the higher cutoff frequency is the modulating signal. So when we calculate the bandwidth formula is higher cutoff frequency minus lower cutoff frequency, and it becomes FM, the modulating frequency. So when the bandwidth is comparable with the modulating frequencies, it is called the baseband signal. So this is the simple and clear cut sign for understanding which is the baseband signal. And apart from this, the bandpass signal, as clearly it is high frequency signal, its lower cutoff frequency. Okay, so this is the next slide because the time limit is there, but I know you all know about the baseband signal and bandpass signal. So as we clear the modulation index and baseband signal and bandpass signal, now the standard and the definition of the modulation. So you can read it here. The modulation is the process of superimposing information content of a baseband signal onto a bandpass signal, that is low frequency signal to high frequency signal. This is another type of definition, that modulation can transfer baseband signal into bandpass signal. You can also see there is three type of the modulation. First one is the amplitude modulation, second one is the frequency modulation, and third one is the phase modulation. Actually, the frequency modulation and the phase modulation is under the angle modulation. But as the definition says, amplitude modulation, in which we can vary the amplitude of the modulating signal and constant is the frequency and phase. Similarly, for the frequency modulation, we can vary the frequency and the constant term is amplitude and phase. And same for the phase modulation, we can vary the phase of a modulating signal and we can keep it constant amplitude and frequency. So this slide can cover the basic definition of the modulation. So depending upon these slides, this is the simple exercise as we can do this. Define the modulation index. So you can define the modulation index, and second one is choose the correct option, that is A signal has lower cutoff frequency equal to its bandwidth is baseband signal and bandpass signal. So you can answer this question. This is very simple. So the modulation index definition is, and a signal has lower cutoff frequency is baseband signal. So next one is the need of modulation. So you can see these two pictures. What is the difference between these two pictures? As we can see clearly, this first picture is the very congested and not systematic arrangement, but in second picture it is systematic and arrangement, and the crowd can pass very systematically and there is no intermixing. So the modulation can do same for this. That is, modulation avoid the mixing of signals and also allow the multiplexing. That is, it prevents signals from mixing together. Okay, so modulation, why we do the modulation? The modulation provide multiplexing and also it allow avoid mixing, because every message signal is superimposed at different carriers. Suppose some carriers is 1 gigahertz, the second one is the 1.5 gigahertz, and third one is the 10 megahertz, and so lots of carrier frequency is transmitted and carries uh, different message signal. So due to the different carrier signal, they are not mixed together, and it is also allow multiplexing. That means same time we can send number of carrier signal with carrying messages. Second advantage why we do the modulation, because it reduces the antenna heights. You can see in this, it allow a practical antenna size. You can see in this picture, when we compare the two cases, I can relate this with this pictures, that practical size of antenna is lambda by 4, and when case 1, when our frequency is message signal has 30 hertz, and in case 2, when the message signal frequency is 30 gigahertz, and we know that the practical height of antenna is lambda by 4, and with this help, with this formula we are calculating the height of the antenna. In the first case, when the frequency is 30 hertz, the antenna size become this much. This is a very huge amount. That is 1, 2, 3. You can read out. In case 2, when we calculate the height of the antenna, we get the 2.5 meter. This is the practical height, and this height can be achievable. So with these two cases, we can simply say that when the message signal frequency is very high, say that in the hertz of megahertz or gigahertz range, we can achieve the practical height of the antenna. And when the message signal frequency is very low, that is hertz or below hertz, then the antenna heights becomes unpractical, that is very high, and it can't be possible to design this type of length of antenna. Okay, so the antenna height is reduced due to the modulation. Also, the modulation increase the range of communication. That means when we use the high frequencies carrier signals, then the short distance is converted into longer distance. That is the large and wider area simultaneously. So you can simply understand that when we are using the high frequency, it can be used for travel longer distances in short duration also. So when we use the modulation, it allows also increase the range of the communication. Okay, So this is the final and last, that what we discussed in the previous slides, that he studies about the modulation. What is the modulation? What is the modulation index? And what is the baseband signal and band pass signal? How we can know the baseband signal and band pass signal, that is the low frequency signal and the high frequency signals. And the need of modulation, that means why we do the modulation, why modulation is important in the communication system, that is the need of modulation. So there are 3 points about the need of modulation. That first one is the avoid mixing and allow multiplexing. Second one is the reduce the antenna heights, and third one is the increase the range of communication. So these are the 3 important points which support we have to do the modulation in communication system. And also the modulation has the 3 types as discussed: amplitude modulation, and we discussed the definition of the amplitude modulation, frequency modulation, and the phase modulation. So this is the mind map of the whole slide what we have discussed. So this is the small assignment for all of you. So read this, list the 3 practical example in communication system where modulation occurs.